Okay, welcome back to the second episode of building a malware lab. As you can see, I have no virtual machines set up. I have completely wiped everything. The only thing that I have at the moment are custom images that we have set up in the previous video. What we're going to do today is use a tool called OpenTofu to help us deploy and tear down the disposable infrastructure that we need on command. If you don't know what OpenTofu is, it is a infrastructure as code tool. It is built under the Linux Foundation and serves as a drop-in replacement for Terraform, which is owned by HashiCorp. This allows us to do infrastructure as code without having to pay licensing or anything like that. So this is why I use it. First things first, we are going to create a Git repo. So we're going to create a new project. This is going to be called U2 Malware Lab. And I'm going to go into it, cd into it, and I'm going to run git init. This creates a empty repository. Now, I run on Nix OS, so that gives me the ability to create development environments quite easily. Your mileage may vary with what you use, but the tools that we need to start with are OpenTofu and Azure CLI. So I'm going to create my first file just to help me set up my development environment. So use devenv, that's my first one. I am then going to create a devenv.nix, and I'm going to import OpenTofu. TFLint is a linting tool for Terraform or OpenTofu. It helps us keep our code nice. Terraform docs and Azure CLI. That is going to configure itself and ensure that I have both Azure installed and Tofu installed. Now, for the first thing that we're going to do is we are going to create the structure of our directory. Right now, I've got just my normal environment stuff and Git. We are going to create a module directory, and that modules directory is going to contain the code for both the Flare VM and the Chasm Workspaces VM. So I'm going to make dir and create the Flare VM directory, and I'm going to create the Chasm directory. Now if I run tree, that's what your project should look like. Now we are going to start with our first piece of OpenTofu code. So I'm going to create a file called main.tf, and that is where we are going to write all of the code for our project. To begin with, we are going to import or declare the Terraform providers that we need. This is the Azure resource, and we're going to define the Azure resource like so. As part of the Azure resource, we are going to create the groups. We are also going to declare the shared image, and we are going to declare the image version for both Chasm and Flare VM. From there, we are going to declare the Azure virtual network that we are going to connect both virtual machines to, and the subnet for that VNet to use. We are then going to declare the resources for the Chasm VM and the Flare VM security groups. This is going to tell each virtual machine what ports are allowed. We are then going to define the network interface security group for both Flare VM and Chasm. We are then going to declare the modules that we will make. This will be the Chasm one, and this is the Flare VM one. Each VM is going to need a resource group name to attach to a location. This is the location of the data center. I'm using Australia East. The subnet that it uses, the image that it uses, the size of the VM that it uses, and the private IP. The next thing I'm going to do is declare the outputs file of our main OpenTofu config. That is going to contain the public IP of the Chasm box, the FQDN of the Chasm workspace VM, the private IP of the Chasm VM, the private IP of the Flare VM, the NIC for the Flare VM, and most importantly, the URL to the Chasm site that you will use to connect to Chasm workspaces. The next thing we're going to do is specify the variables we want to pass into our configuration. We're going to start with the location. This is the region for the Azure deployment. I am defaulting to Australia East. You can choose whichever one you want. The resource group name, in this case I'm calling it detonation. These defaults are something that we can put in so we don't have to specify them ourselves. This is a better alternative than hard coding everything and then having to try and change it at a later date for whatever reason. The VM gallery name is going to be for Chasm workspaces for Chasm. This allows us to specify the virtual machine image that we are going to use to create the virtual machine. We are then going to do the same for Flare VM, and we are going to specify the image for Chasm VM and Flare VM. We are then going to specify the Azure config that we are going to be using for connecting to Azure. This includes the subscription ID, the tenant ID, the Azure Client ID, the Azure Client Secret. These are both sensitive variables, so we are marking them sensitive. We're then going to specify the allowed public IP to connect to Chasm workspaces. This is to keep the Chasm workspace app locked down so only we can see it. We're going to specify the image version that we deploy. We're defaulting to latest. We're going to define the size of both VMs, the private IP of the Chasm VM, and the private IP of the Flare VM. These are static, so we can make this as replicable as possible. That is all that we need for this file, so we are going to save and quit. The next thing we're going to do is create a Terraform vars file. This is going to allow us to set the variables that we need to connect to both Azure as well as the VMs inside of Azure. So the file that we're going to create is going to be called terraform.tf-vars, and to begin with we are just going to create an example file. That example file is going to contain the IP of your public IP. This is going to be used to whitelist the rule group inside of the security config. We're then going to define both compute galleries that we use to pull the virtual machine images for both Chasm and Flare VM. We're also going to define the Azure authentication credentials so you can connect to Azure through OpenTofu. We are also going to configure the VM admin credentials. This is not really something that you will use, however it is a requirement inside of OpenTofu to have this. That is all we're going to set for this file, so we are going to save and quit. The next thing we're going to do is look at writing the Chasm OpenTofu config. So we're going to create a file in modules Chasm and a main.tf. Inside this main.tf file, we are going to define the Terraform provider random. We're going to use that to generate a random ID, and we are going to use that random ID to create unique public IPs that we can use. This is to prevent collisions between label names. If we just choose to spin up more, you can use any other type of randomness to do this. Random ID with a suffix 4 bytes is fine for me. The next thing we're going to do is create the network interface. This is going to tell us the network that Chasm is going to use, as well as the subnet, the IP, and the rules that it will use. We are then going to define the disk that Chasm is going to use. This is from whatever you want. We are then going to define the virtual machine itself. It's going to contain the name, the location, the resource group, the size of the disk, the OS that it's going to pull that disk from, the network interfaces. It is also going to define the image that it uses, which is where this plan comes in. Also set the caching and the boot diagnostics to null. That is all we're going to do for this file, so we can happily save and quit. The next thing we're going to do is create the Chasm outputs file. So in module Chasm outputs, in this file, we are going to specify the public IP that we want outputted, as well as the FQDN for that public IP, the private IP of the VM, the NIC for that VM, and the ID. We're going to save and quit and move on to the next one. Next, we're going to create the variables file for the Chasm VM. This is going to contain the resource group name, the location of the VM, the subnet of the NIC, the image ID that we're going to use, the size of the VM that we are going to use, the private IP we are going to set for the VM, as well as the marketplace plan information for the image. The reason why we need to do this is because the Chasm workspaces image that we originally used requires this. If we created a Chasm VM image from scratch, this would probably not be necessary, but it is in this case. That is all we need to do to this file. The next thing we're going to do is declare the configuration for the Flare VM virtual machine. So we're going to create the main.tofu file under modules Flare VM. Inside that file, we are going to declare the network interface for the Flare VM to use, the disk that the Flare VM is going to use, and the virtual machine image specification. This is going to contain the name that we're going to set the VM, the location, the resource group name, the size, the disk, the NIC, and the boot diagnostics. Next, we are going to specify the outputs that we're going to use. The file is going to be modules flavm outputs.df. In this file, we are going to specify the private IP of the FlareVM, the NIC of the FlareVM, and the ID of the VM. That's all we need for this file, so we're going to save and quit. Next thing we're going to do is create the variables file for the FlareVM. So we're going to create a file called inside modules FlareVM and call it variables.tf. In this file, we're going to specify the resource group name, the location, the subnet ID that we use, the image ID that we pull from the Azure Compute Gallery, the size of the VM, and the private IP of the VM. That should be everything for the OpenTofu configuration. To initialize this, we are going to run tofu init, and that is going to pull down all of the providers, the back end that we need to start running this. Once that has been finished initializing, we are going to copy the Terraform TF vars example into Terraform TF vars, and we are going to edit it. Inside of this file, we are going to set the chasm allowed source IP to your public IP. We are also going to specify the Azure credentials. Now, to get these credentials, we are going to go back into our Azure portal. We are going to go to the search bar. We are going to search for app registration. As you can see, I have one here, but I'm going to create a new registration. I'm going to call it YouTube Tofu. We are then going to go to API permissions. We're going to check that the API permissions has the user read. We're going to go into certificates and secret, and we're going to create a new client secret. You can call this whatever you'd like and choose whichever expiry date you want. We are then going to take this value from the secret. This is the secret that you will use to authenticate. We're going to go back into our project, and we're going to set the Azure client secret to this value. We're going to go back into our app registration, and we're going to use these values for the rest of the variables. So the application client ID is going to map to the Azure client ID. The directory tenant ID is going to map to the Azure tenant ID. And to get the subscription ID, we will need to go into all resources, Azure subscription, and you'll see your subscription ID up here. That will map to your Azure subscription ID. From here, we are going to save and quit. We need to set the role assignment for the application, that registration that we have created. To do this, we are going to run az login and use the SSO to log into your tenant. I'm not going to run this because I have already done it. The next thing we are going to do once you have logged in is use the Azure CLI to create the role assignment for your app registration. This is going to be the assignee is going to be your application client ID. The role is going to be contributor. The scope is going to be subscriptions, your subscription ID, resources, and your resource ID. You will hit enter, and that will set your role ID. Once that is done, we can now run Tofu plan. This will create a plan for OpenTofu to run. I use this as a way to validate the config to make sure that everything is right. This won't catch everything, but it will catch most things. We can ignore the undeclared variables for now. The next thing that we can run is tofu apply, and that will run the deployment. Once it creates the plan, it will ask you if you want to perform these actions. You will type yes, and it will go and try and spin up your virtual machines. Cool. We can see that the command has finished running, and we have the outputs that we want down here. We can go back into our Azure portal, click into virtual machines, and we can see that we have a Flare VM virtual machine running and a Chasm VM virtual machine running. What we can do is we can take this URL and we can run it inside of our browser. We still have the security warning from Firefox, but we can just proceed. That pops us into the Chasm workspaces. I can then go and log in with your username and password. We are logged into Chasm workspaces. One thing to remember is that the password, if you're using the default username or password, is the original name of the virtual machine that you initially created in the previous video. But we can now go to workspaces and Flare VM and open it into a current tab, and we can see that it is loading. We can see the virtual machine has loaded, and we are now in the Flare VM machine ready to detonate malware or break it down. To get this to run and configure automatically, there are a few things that we need to do, and it is the reason why we have set static private IPs. The first thing we're going to do is in infrastructure servers, we are going to ensure that we have the Flare VM created running on IP 10.0.0.11 and authenticated properly. We are then going to make sure that the Flare VM workspace is configured to directly pull from that. Once that has been confirmed working, we can create a virtual machine image from Chasm workspaces, and that means every time we spin this up, those settings are always set for us to use. So we don't have to set any of this stuff up anymore. We can just go into Chasm workspaces, Chasm and Flare VM, and it will just work. Once we are happy with whatever work that we do inside this VM and we want to destroy it, we can then go back into our project, and instead of running tofu apply, we can run tofu destroy. You can use this auto approve flag, and that will just mean that you don't need to type yes to confirm that you want to create or destroy the VMs. So I will do that now just to demonstrate that it works. As you can see, the destroy command has finished running, and we can see if we go back to our browser, the session is closed. If we close out of this, when we go back to our portal and hit refresh, we can see that there are no virtual machines to display. In fact, if we go to all resources, we can see that the only resources that exist in our resource manager are VM versions, the Azure Compute Gallery, which stores the VMs and the VM definitions, and also this network watcher, but we don't currently control this, so we can safely ignore it. One other thing that we can do before we commit and push this project to GitHub is create our git ignore file. So we can create a .git ignore. In this file, we can specify the Terraform directory, the tofu states, crash logs, the overrides, results. This is something that you probably don't need to worry about, but this is on my side, and all of the other ID related and OS related files. We can then run git add, so add all of the files. In fact, it looks like it's trying to add the .terraform files, so I'm going to uncache that. In fact, I'm going to uncache. Cool. I'm going to do the same with my dev env. It was a mistake that I made earlier. With that, we can see all of our new files ready to be committed. So just run git commit, and we can just call it init, or a better name if you want. And with that, we have a project that spins up and tears down your malware infrastructure on demand. I hope you found this video useful. If you have any questions, please feel free to comment. I can do my best to answer anything that I may have missed, and I shall see you in the next one. See ya.